The artificial intelligence pulse oximeter medical system sends data enabled by Bluetooth technology. The data is sent over the link to a laptop, desktop, or smartphone, thus giving the capability to display the information. The plethysmographic trace waveforms, which is oxygen saturation, that is SpO2, including heart rate data. The pulse oximetry system is used as a non-invasive method to measure arterial oxygen saturation in the blood stream. The need for monitoring the cardiorespiratory vitals as part of the health of a human stems from a biological study of normal oxygen transport in the human body, which is done via the pulmonary and respiratory blood circulation systems. Typically, the process begins as the consumption of inspiration of air through the nose or mouth and ends after the delivery of oxygen to the system of the body and subsequent relaxing, releasing, or expiration of carbon dioxide from the body, and includes several sub-processes. The sub-processes included ventilatory control, diffusion to blood, bind to hemoglobin, circulation, and diffusion to tissue. The ventilation consists of the breathing in of air and the path of air takes into the lungs via the larynx, the trachea, and the bronchioles. Once inside the lungs, the alveoli diffuse the oxygen to the blood, as I have shown later on in this specific project application. The diffusion occurs through the hemoglobin, which is used to transport the oxygen that is diffused into the blood. The oxygenated blood arrives to other tissues in the body to irrigate them and oxygenate them. The efficiency of this transport mechanism and overall system performance is analyzed and used to calculate the individual within the realm of pulse oximetry. So, oxygenated hemoglobin and deoxygenated hemoglobin have different properties, and these are used to calculate the SpO2 of any individual. The initialization software model resident in the firmware initializes the basic functions of the neuromorphic CPU system, such as clock initialization. First, the function copies the vector table to RAM, that is memory, and clears any pending interrupts on the USB. It enables interrupts from the USB module. At this point, the phase-lock loop initialization is called. This function configures the neuromorphic architecture to run in PLL mode, phase-lock loop mode, at approximately 96 megahertz of the core speed with 50 megahertz clock to generate a system bus frequency. It is important because the USB module needs 48 megahertz to run correctly. After the PLL initialization, the neuromorphic architecture is cleared and the clock gating for USB is configured. There are two important organs in our body, that is the heart and lungs. These two organs work together without us noticing, and the primary function is to exchange oxygen and carbon dioxide. The primary goal for the lungs are to extract the oxygen from the air and deliver it to the bloodstream. Carbon dioxide needs to be extracted. Pulse oximetry makes use of two wavelengths of light, which are specifically chosen for system performance in the absorbing characteristics of HB and HbO2. The two wavelengths are shown periodically on the tissue of interest, and a photodiode detects the light that is either transmitted or reflected by the tissue. Because the pulsatile nature of arterial blood, the light detected also has an alternating intensity level, which can be used to determine arterial oxygen saturation. The complex mathematical algorithms and software development consist of signal processing. The file was arranged to get a matrix of 4 columns where direct current and alternating current, infrared and red values are stored with the following filtering techniques. The low-pass filter consists of an FIR filter and IIR filter, the Butterworth filter, the Chebyshev filter, and elliptical filters. At the bandpass filter level, the FIR filter is also implemented as it was previously stated. The different input values for cutoff, passband and stopband frequencies. The passband and stopband attenuation were calculated with the software mathematical libraries. Changes in signal to noise ratio and oxygen saturation were also evaluated. The filters were made with the fast Fourier transform also included in order to retain as much information as possible after the signal processing. In Python, the numerical toolbox SCIPy includes NumPy and Matplot library. NumPy, which is a utility routine, reshaped the output to a matrix and later plotted with the use of Matplot library for use to import suitable filters and filtering techniques. In this segment, I illustrate the framework of the state-of-the-art artificial intelligent pulse oximetry SpO2 cardio oxygenated medical integrated workstation. It is actually an engineering prototype for solutions of different medical applications previously explained and demonstrated in this specific video. The software models were developed with Python and C++ algorithms and augmented with the implementation of a digital arterial pressure unit, including SpO2 for pulse and blood oxygenation measurements, as well as a pulmonary ventilator system. These elements comprise the artificial intelligent medical integrated system. The need for smart ventilators is evident. Patients with COVID-19 present symptoms from lack of oxygen in their lung capacity. The best medical treatment is to assist the lung function with the electromechanical ventilation system. The BVM is a plastic balloon or plastic bag that can be manually compressed without having to perform mouth-to-mouth resuscitation. It is an easy and simple way to force air into the lungs. The challenge is how to manage the supply of oxygen into the patient's lung and managing the side effects caused by the electromechanical ventilation system, such as barotrauma. Alveoli allows to diffuse the blood in the lungs. They are tiny air sacs in the lungs that are in contact with the blood vessels to allow oxygen and carbon dioxide to diffuse between the blood and the lungs. These are very delicate pieces of tissue. Overexpanding them will lead into inflammation. This is what is also known as barotrauma. The spirometer is an important feature to measure the airflow rate out of the BVM to calculate the amount and volume of air delivered, typically 200 milliliters of volume up to 750 milliliters. Here the smart microcontroller can measure and control the volume and the pressure parameters. The time-based frequency of the system ranging from 5 to 30 breaths per minute. This is the mandatory breath. At this point, the patient must be heavily sedated. The machine needs to trigger the breath cycles and ending the breath cycle as well. The embedded CPU will detect and control the breath trigger and timing. There are a multitude of other design parameters and considerations that need to be taken into perspective. The ventilator paradigm is controlled by a sophisticated neuromorphic embedded system to allow exact adaptation of pressure and flow characteristics. Fine-tuned ventilator settings also serve to make ventilation more tolerable and comfortable. The artificial intelligence microprocessor pressure ventilator consists of a compressible air reservoir, air and oxygen supplies, a set of valves and tubes, and a disposable patient circuit. The air reservoir is pneumatically compressed several times a minute to deliver room air and air-oxygen mixture to the patient. The ventilator with a flow valve adjusting pressure to meet patient-specific parameters. When overpressure is released, the patient will exhale passively due to the lungs' elasticity. The exhausted air being released usually through a one-way valve within the patient circuit called the patient manifold. The software platform consists of complex mathematical algorithms and sophisticated software models. Many of these models are developed with Python and C++. The main objective is to provide the control environment for the motor and sensory segments. Here, I will illustrate an engineering alpha test model of the proposed ventilator system.